All right, so by way of introduction, since I don't think I know anyone in this meeting, my name is Yuri Grinstein. I am an SRE, Site Reliability Engineer at Google, specifically at Google Cloud. Today, I am going to talk about this kind of list of topics. We're going to basically talk about kind of a basic introduction to the fundamentals, right? We're going to talk about what are SLIs, SLOs, SLAs, what do those terms actually mean? And then we're going to talk a little bit about how to choose a good SLI. Like when you have lots and lots of metrics that your services are exposing, what metrics actually make for good SLIs? What are some of the characteristics of these metrics that you should be looking for as you determine which ones to use as a real indicator of user happiness? From there, we're going to talk going to get into some more specifics, some practical stuff, some SLIs that are available for your workloads running in Google Kubernetes Engine and Compute Engine. And from there, I'm going to show you how to actually implement some of these using Google Cloud Monitoring. And I'll show a couple demos as well. So let's get into it. Let's talk about what reliability really means. The number one thing I think I would want everyone to believe after this presentation, if they don't already believe it, is that reliability is a feature of your service, of your application, in the same way that everything else that describes how it functions and how it behaves is, right? Which means that you have to do things like plan for it, design for it, architect for it, build and deploy and maintain it, right? But how much reliability do you really need? Well, by now you probably have heard this, right? 100% is just about always a wrong reliability target. But why is that? Well, there's a couple of reasons for that. The first one is just from a practical standpoint, right? Your services, they can be as reliable as they could possibly be. But by and large, your users aren't going to be consuming your services over perfectly reliable connections. And so in a way, any investment in reliability above and beyond what your users will actually perceive or what will actually improve their experience and their happiness is basically wasted. The second major reason is because it's actually really difficult to materially improve the reliability of your services, right? So if you look at a service that we consider to be what we refer to as 3.5 nines reliable, right? 99.95% availability. That basically means that in any 30-day window, you can take a 21-minute, 22 minutes almost outage. 22 minutes in a given month basically means that for a single outage, you have to detect that an outage is happening, figure out what the problem is, or at least what you can do to restore the service to a good state, take that action and validate that it's actually working. And it's really difficult to do that unless you have really good automation, really good rollback procedures and things like that. And so as you move kind of higher up these reliability levels, it becomes much more and more expensive to achieve that. Kind of the rough rule of thumb is that it generally increases the infrastructure, automation, and engineering costs of your services by tenfold to get one additional 9 of reliability. You might say, well, that's fine, but our service is already multi-regional or multi-zonal. We're never going to take a full outage, right? So we should think 100% is still doable. Well, you can still model reliability using a partial outage model, right? For that same service, in a case where you may be serving, instead of a total outage where you're serving 100% errors, if you only are serving 1% errors, that can be the case for about 36 hours before you have exceeded your reliability target, right? And so these numbers that kind of tell you just how many errors you can serve over a period of time, that is essentially what's known as your error budget, right? Sorry, I went the wrong direction. Error budgets is how you define your availability target, right? It's basically the difference between 100% availability and your reliability target, right? And I think the second big thing I would like everyone to leave this presentation with is that 100% is the wrong target. So you should have a good target, and I'm going to talk about how you might set those targets next in just a second. But the error budget that you actually have available is how you increase velocity, right? The goal is not 0 outages. The goal is to be within your error budget and maximize velocity within that, right? So any error budget that you do not use for things like releases or experiments is in a way wasted, right? It's an opportunity for velocity that you're not actually taking advantage of. So ultimately, error budgets drive velocity. They're not an impediment to velocity. In order to actually put these into practice, you need to have some fundamental terms defined and understood, right? Here's how we talk about these things, and it really boils down to 3 terms. SLI, which is your service level indicator. This is the measurement. This is the metric that you compare that tells you for any moment of time if your service level is acceptable or not. The SLO, the service level objective, is the goal for the aggregate of the SLI over a window of time, right? It says over this window of time, this is my target, and the amount by which I exceed the target adds to my remaining error budget. The SLA, or the service level agreement, is really mostly relevant to a business. It really defines what you're willing to do, what costs or consequences you're willing to incur if you fail to meet the objectives that you promised to your customers. And they may be things like, refunding money potentially, right? So now that we've kind of understand some of the basics, let's talk about how do we choose good service level indicators? How do we choose good SLIs? Well, imagine this scenario, right? Our goal is to really determine when our users are happy, right? So the happiness test says that our service level objective should really represent the clear dividing line between happy users and unhappy users. And we can't really measure the happiness of users directly. So we have to find some way of approximating user happiness using metrics that we can measure, right? And we start by restating our principle, which is users become unhappy when the service they're trying to use doesn't behave the way they expect it to. So if you want to understand the reliability of the service, you have to measure its performance from the perspective of your users, right? It doesn't matter if the database is down or if it's a load balancer that's sending the request to bad backends. From the user's perspective, this all collapses to it does not load, and now I am unhappy. Similarly, it doesn't matter which component of the system is responding slowly. The user experience is this is slow, and I don't like it, right? So if we can find ways of quantifying this is not loading or it's slow from our monitoring data, we can actually tell how unhappy our users are in aggregate, right? So let's consider how this works in practice, right? The interval of time in the middle is when our users were unhappy. And we know that they were unhappy because we had a whole bunch of support requests. Now, you could say, okay, well, why can't we just use support requests as our SLI? There's a few reasons for that, right? One, it's actually a trailing indicator. It does accurately measure unhappy users, but it doesn't really help us if we're trying to be more proactive. The second thing, users who are unhappy with the service will just stop using it, right? Because the burden of actually making a support request is too high for them. And we need to capture their experience as well. And finally, when things are good, we're not going to have any signal, right? So we can't really base an error budget using this SLI, right? But we have lots of metrics that we're collecting. So I'm sure we can use some of them, right? So we're going to look for a metric whose value changed over this time that we think correlates with user happiness, right? So what properties of a metric might make it good for use as an SLI? Let's take an example. We've kind of looked through our metrics and we say we got a couple that we think kind of closely correlate, right? If we had to choose between why is the one on the left bad and the one on the right good? The bad metric does show like this obvious downward slope during the outage, but there's a lot of variance during that outage, right? And the expected range of values that we see during normal operation, shown in the blue on the left-hand side there, has a lot of overlap with the expected range of values during the outage, right? So you got a lot of variance here and you got a lot of overlap between bad and good. That's not great. On the other hand, on the right-hand side, our good metric has this noticeable dip that matches closely to what we saw our outage. During normal operation, it has a relatively narrow range of values that are very different from an equally narrow range of values that we see during the outage, right? Which means we have a stable signal. It makes trends visible and meaningful. So this is a much better indicator of user happiness, right? This matters because SLIs need to provide a clear definition of good and bad events. And a metric with lots of variance and poor correlation with user experience is actually much harder to set a meaningful threshold for. Because the bad metric, right, has this large overlap in range of values, we basically have a few choices here. We could set a tight threshold, which will trigger a lot of false positives, We can set a loose threshold, which risks lots of false negatives and missing problems. Or we could try to compromise between the two, and then we're accepting the risks of both. The good metric on the right, we can set a threshold against it much easier, right? There's no overlap between good and bad. The biggest risk we have to contend with here is that it doesn't recover as quickly as we might have hoped for, right? Because when the outage ends, we can see it kind of starts to recover and takes some time. So as long as we're aware of that, as long as we know that the recovery rate is a little slower, we can live with that. Okay. So then, how do we actually express this SLI, right? Generally, we want to express these as a proportion or set of events, basically proportion of good events over valid events, right? And if we try to express all of our SLIs in this format, this gives us a couple of useful things. One, everything is between 0 and 100%. 0 means nothing works. 100% means nothing's broken, right? Very intuitive and easily translates to percentage-based SLO targets and error budgets. Secondly, we have a consistent format which can use as an interface for abstraction. So now you can use common tooling around all SLIs. Things like alerting logic, error budget calculations, reporting can all expect the same inputs: good events, valid events, and the threshold, right? One thing you might be asking is, well, why do we say valid and not total, right? Because sometimes you might need to exclude events being recorded by the metrics from the SLI, so don't consume error budget, right? So one example might be ignoring 300 and 400 HTTP responses from your SLO performance, because those are essentially client errors, right? So the phrasing of valid, right, allows you to make these exclusions specific, because you actually have to explicitly define what valid means for your service, as opposed to just saying we're going to count all events, right? So this is how we recommend you actually express SLIs. And, it may be tempting to go off and start building them, but we have like one last recommendation is you're typically going to want to have, fewer SLIs is probably going to be better than more, especially as you get started, right? In general, your users are using a service to achieve some set of goals, and so your SLIs should capture their interactions with the service in pursuit of those goals, right? So we use the term user journey or critical user journey. This is something we've borrowed from from user experience research, rather. I'm sorry. You should have at most 3 to 5 SLIs per user journey, right? Even if you have a complex system with complex user journeys. If you have too many SLIs, it's just too much cognitive burden on the folks operating on the service, too much for on-callers to deal with, and you can get to a point where you actually have contradicting SLIs. One thing I want to really make clear here is this is not a recommendation that you should ditch your other monitoring or certainly ditch observability pursuits, right? However, SLIs is what we recommend that you primarily determine that there is a problem and that the problem is bad enough to warrant additional work, especially additional incident response, right? You'll need other metrics. You'll need kind of robust observability capabilities once you know that there is a problem. So now let's talk about some specific examples, right? I'm going to talk basically about 2 different services. We're going to talk about services running on Kubernetes, specifically in Google Kubernetes Engine, and services running on virtual machines, specifically in Compute Engine, right? So in Google Kubernetes Engine, right, you basically have 3 kind of easy options for SLIs or service level indicators. You have Istio, you have Prometheus, and you have custom metric instrumentation with OpenTelemetry or OpenCensus. So if you're using Istio in your clusters, right, the Istio proxy sidecar automatically sends metrics like server response latency, request counts, and errors to cloud monitoring. These metrics are automatically labeled with things like destination service name, et cetera. So you kind of have a very good sense of like what's talking to what, both from outside the service mesh into the service mesh, as well as from within the service mesh as well. I know someone on the call said that they're, working with Linkerd, kind of similar approach here, right? This is a great option if you're on GKE, if you use a service mesh like Istio. And honestly, a lot of folks that I've talked to find that the telemetry value that they get from Istio is actually reason enough to use it even if you don't use other features within it. Your second primary option is Prometheus, right? This is kind of the de facto standard for monitoring in the Kubernetes ecosystem, right? There are lots of integrations available. This is a very robust and kind of mature solution. The one trade-off is it does require you to then maintain additional infrastructure if you're trying to get these metrics specifically into cloud monitoring. And then finally, so the way that actually works is that you basically deploy a sidecar into your Prometheus server that takes all the Prometheus metrics and ingests them into the Google Cloud Monitoring backend. Your third option is to essentially use custom metric telemetry through either OpenCensus, which is at this point being merged together with Open Tracing into a single library called OpenTelemetry. And so when we get into the demos, I'll show you how metric instrumentation works in OpenCensus and how you might use it to actually instrument your services for SLIs. In the compute engine world, if you have a service that looks kind of like this, where you have basically a managed instance group with a bunch of VMs in it that possibly auto-scale, in front of a cloud load balancer, right? Then the good news is that you could actually use all of the load balancer essentially exposes SLI metrics just out of the box. So you get things like request counts broken out by response class. So you can basically filter out your requests, and you can use latency metrics as well, right? So you can actually use latency as an SLI. You do want to consider when you're configuring SLIs using latency, whether you want to include all response codes or just the quote-unquote valid ones, right? It might be important to know that, hey, when we have errors, they actually take a long time. Or vice versa. You say, no, we only care about latency when things work, and when there are errors, we're going to treat that as like a separate SLI entirely. All right, so that's a decision that you make as you go to implement some of these things. So those are some of the examples of the kinds of metrics that you might choose to use to set up SLIs for your services running either in GKE, Kubernetes, or GCE compute engine. So now, let's take a look at some specific demos, right? So I've got kind of 3 specific examples for you here. So the first one is I'm going to look at a kind of the easiest case, which is I've got a service that's running in Google Kubernetes engine. It is running within a service mesh, specifically Istio, and Istio is exposing telemetry metrics. How can I go about configuring an SLI in cloud monitoring using that? So I'm going to let's do a new share. In this case, I'm just going to share my desktop just so we can all see everything. And can you see my screen now?
Yeah, we see something that says Google Cloud Platform.
Okay, so this is the Cloud Console. It's loading. So I'm going to go to basically I'm going to go to the Services tab under Monitoring. And as you can see, one of the cool things that happens here is that in my project, I have a Kubernetes cluster. It's called Demo Cluster. No surprise, it's got the Istio Service Mesh. And all of the services that are exposed by Istio, or essentially they're managed by Istio, are automatically captured. So I can pick one of these services. I can say maybe my product catalog service. If I click on it, you can see that I already have an SLO defined for it. But I'm just going to create another one. So I'm going to say, okay, let's go ahead and create a service level objective or an SLO for this particular service. Because it's Istio, it already understands things like, well, I want to use availability or latency. So maybe since I already have an availability, let's do latency. I want to do a request-based SLI versus a Windows-based, right? So request-based, right, counts events. Windows-based counts good minutes versus bad minutes that we can use to define a criteria, but we're just going to do request-based. Whoops. And now it automatically selects a latency metric, which is great, right? It shows me what my latency has been for this particular service, right? So my 95th percentile latency is just under a second. So maybe I'll say I want my latency threshold to be 1,000, and I say next. And I want to do a rolling, maybe 7-day window, and I want to say, basically the way I'm going to define my SLO is because I said my threshold is 1,000 milliseconds. And now I'm going to say I want 99%. It looks like it's actually none of them. So let's say I want, I think that's in, well, I'm doing something wrong here, but this is the general idea. So I'm going to, basically it shows me what my service looks like against, it looks like my service, actually my service is so fast that it's just, this is actually 1 millisecond. So I'm going to put 1 as the threshold so that we have a better graph. Yeah, there we go. We're still, I'm basically at under SLO for this point. Let's do 10. Okay. Now it's basically, this is my goal. So my goal is going to be that 99% of my requests have to fall under my target for every rolling 7 days. I say next. There is my latency. Let's see, under 10,000 milliseconds, rolling 7 days. Submit, and now it creates my second SLO. Right? You can see I'm in compliance. I have 100% of my error budget left. I can click on this SLO to then get information about my service. You can see that here's my SLO compliance, my error budget. All this information is easily available. From there, if I want, I can go ahead and create an alerting policy if I want to be notified if my latency degrades. It creates an SLO burn rate alerting policy that basically allows me to specify 2 things, which is basically how quickly am I burning error budget. 60, what percent of my error budget, which is a threshold. So I would say maybe if I burn 20% of my error budget over 60 minutes, send me a notification, and I, hit save, and there I am. And then I can do things like, here's my condition, I can name it, I can add notification methods, etc. So that's my first example, right? Which is creating SLOs for GKE services on Istio. The key things there was the service is automatically recognized, so I don't have to do anything to create the service. All I do is pick an existing service and create SLOs for it. My next example might be a custom service, also running in GKE, not using Istio. Okay. The way it's going to work now is, I'm going to go back to services, is I'm still going to use the UI, but now I'm actually going to define a service first. So I've got all these services that are recognized using Istio, but I'm going to define a new service. And it's going to allow me to select essentially a Kubernetes primitive, right? So I have, I think, a service that I've deployed that's essentially using OpenCensus. I'm going to show you the code for that service right now, right? So this is a pretty basic Node.js app, right? All I'm really doing is I'm using OpenCensus to create a few different metrics. So I've got a request count metric. And the way OpenCensus works is that you essentially you create what's called a measure, and then you create a view, and then you register that view to start tracking that metric. And here is where I've got my, what used to be called the stack driver exporter, now it's the cloud monitoring exporter that basically sends this information to this particular project. So I've got a request count, I've got an error count, and I've got a latency, right? Specifically for latency, because I'm doing it as a distribution metric, I actually have to explicitly specify the buckets, right, in order for it to group requests into these different buckets. And the way that this app works, this is very simple, is basically every time I get a request to the root, I start a stopwatch, I increment my request count by 1, okay? Then I just do a random number, and if it's 10% of the time, I throw an error and stop my stopwatch. And if that's the case, then I also record a error count. Otherwise, I just delay for some amount of time, send a success, stop my stopwatch. All right. So that's kind of what this app doing. It's pretty basic. It's the idea that it's basically just doing a random delay, and it's throwing error, 10% of the time, and doing a random delay the rest of the time, and then just logging my latency using a timer. Okay. So now, when I go back to here, I look for my OpenCensus metrics deployment or a service. So it's going to use, I can create, so there's my deployment. So I'm going to create this is going to be called my OpenCensus SLI service. So now that just creates the service. Now I can actually create the SLO for that service. Right? So when I go to create the SLO, I again have the option of basically using an advanced option to create a custom metric. So I want this to be a request-based SLO. I'm going to say next, and now I want my, let's see, I think it's response latency. There's my custom open census response latency metric, right? And again, I want it to be, let's say I want it to be less than, specify the resource. This is going to be Kubernetes pod, I believe. Oh, no data is available. Let's try Kubernetes container. Maybe this metric is actually not being written right now. Well, in any case, I specify the threshold that I want, so maybe 4,000 milliseconds, and then again, I'll specify a rolling 7-day window, and I want 99% of my requests to be less than 4,000 milliseconds in response latency. I say next. There's my distribution cut SLO, and I submit. So here again, now I have my my service. I have my SLO. I can, let's see, looks like it thinks it's healthy. It actually, I think, is the case that it's actually not collecting data at all. So probably shouldn't be reporting as healthy, but nevertheless. So that's how I would go about configuring a SLO using cloud monitoring for a GKE service that is not managed by the Istio service mesh. I would define that service in the UI by using my GKE primitives. In this case, I chose a deployment, but I could also choose a service or a namespace. And then from there, I can pick the metrics that I want to use for SLIs for that particular service. There you are. The third example I wanted to show you is creating SLOs for services running on Compute Engine. So as you may remember, I have a basic service that's basically a managed instance group behind a load balancer. And I want to use the load balancer metrics as my SLIs. But I don't, if I go to services in monitoring, right? The limitation that is currently the case is that I can only define new services, right? When I hit define service, it forces me to use a GKE entity. But my service is not running on GKE. So what do? Well, thankfully, we have API support for creating these kinds of services. So I'm going to switch to a tool called Postman, which is essentially just a way to send API requests. And I'm going to send a very simple service service request to cloud monitoring. If I've configured everything correctly, I hit send. There's my response. There's my service. And now when I go back to services and I refresh this particular page, probably take just a second. And now I sort by type. There's my custom service, my GCE service. Okay, you can see it doesn't have any labels or anything like that. No SLOs are created. It's literally just a shell. And then from there, I can again create an advanced SLO for that. And I'm going to say next, and I'm going to say I want this to be a load. Let's see, HTTP, and then I can send. There's my. I can basically pick the metric that I want. Which is load balancing. I can set, so I can use total latency, for example, for my load balancer, right? So let's use total latency. Here's what total latency looks like. Looks like it's about 200 milliseconds. So I want this to be maybe 300. Okay. Say next, and I want this to be a rolling, again, 7-day SLO, and I want 99. Maybe this time we'll make it a little tighter, 99.9%. And there we are. Right, so I can configure, once I define the service using the API, I can again go in and add SLOs in the UI. So that's pretty much what I wanted to show you all today, right? The summary of the talk is, first and foremost, right, air budgets are a way to improve the velocity of your services by getting kind of the shared sense of reliability between development and operations. You should use SLIs as a proxy for user happiness to really understand the user experience that you're delivering to your users. The recommendation is to start simple, right? You don't have to get complex. As you saw, what I showed you here is kind of the very basics. Error rates, latency. Those are great. Availability and latency are always the first two places you should start if you have nothing else. You can always iterate from there and get better. And hopefully you've seen how you can use service monitoring in Google Cloud Monitoring to implement this. So that's what I've got for you today. Thank you so much for your time and attention. If there are any questions, I'd love to try and answer them.
This
Okay,
looks
so
great.
if you have any questions, you can unmute yourself. Everybody is muted right now, though.
I have some questions. So you have service level indicators and you have service level objectives.
Mm-hmm.
And then when you're not meeting your objectives, how do you get to your objectives? And how do you improve? Like, it's great that we can measure that, you have service level indicators and you have your service level objectives, but
Yeah.
when you're not meeting your objectives, then what do you do?
Yeah, that's a great question. And the answer to that is determined in advance of failing to meet the objectives. Right? If you're just starting out, it is not the idea that you would say, well, we have a service that's currently only delivering, 95% availability, but we're going to set our target at 99%. And you're sort of starting out in the red, right? It's unrealistic. And because in
Right.
practice, what you should be doing is anytime you're basically out of error budget, or even if you're getting close to the error budget, you really shift the priority of the work done by both development and SRE to reliability, to improving the reliability of the service until the service recovers to the point where it's again meeting its reliability targets. If you're at a point where you're not able to meet the objectives that you set to start with, then those objectives are not realistic, right? You should kind of do both things. You should work on the reliability of the service, and you can do things like well, it honestly depends on why it might not be meeting its targets, right? So if it's not keeping up with traffic, maybe you need more capacity. If it's just too many errors, maybe you need better debugging and better CI/CD or whatever the case may be. If it's too many outages because of changes, then maybe you need better change management or infrastructure as code or whatever the case may be. So it kind of depends on what is the problem as it stands and how do you fix that. But if you start with a baseline of saying, okay, here's where we are today, and we're going to kind of work to both improve the reliability of our service, but we're also going to set targets that actually make sense both for us and for our users. Then what you do when you fail to meet that target is it's basically you kind of shift. It's a shift of priorities. You say like, well, we're not going to do anything until we start recovering error budget, until we are at a point where the service is healthy again. And the thresholds for when do you trigger an alert? When do you declare an incident? When do you shift engineering and SRE or DevOps resources to work on that is something that you would define in advance.
Yeah. And the thresholds, I guess, I mean, earlier on you said, you can measure it by the number of tickets that are coming in, but at the same time, you can set your thresholds at 99%, or like you said, you can set it at 95%, depending on what your application is. And if you're in beta, for example, you're not going to be at 99%, right? So, yeah.
Absolutely, and SLOs are also something that it's something that changes over time, right? So, like you said, right, if you're getting ready to release a new service, you might start out with fairly loose SLOs because it's in beta and maybe people don't care that much. They have sort of very loose expectations of reliability. But as the service reaches, general availability and eventually starts making money, then reliability may become more important. However, kind of the other side of that coin is that making your service more reliable also costs money because it costs you infrastructure, it costs you engineering, it costs you automation efforts. And so you have to find the right place on that spectrum to say, like, basically, we're going to make it exactly as reliable as it needs to be and not more than that, because any more reliability is just money that we're spending that we're not getting a return on. So you have to find that inflection point of where does our user happiness where do we see diminishing returns on either user happiness or maybe even revenue from improving reliability. And that's a non-trivial thing to do, but it's something that's generally done in conjunction between product management, development, engineering, operations, or SRE. Kind of everyone who's involved in that kind of has to come together to agree on that, because you have folks like product management who understand the user base and the requirements and the revenue implications. But then you have SRE who understands the practical implications of delivering specific reliability targets.
Yeah. So I have some other questions, but I'm going to stop and wait for others to ask their questions if there's any. So go ahead, guys.
Hi, I have a question. So the values of SLI are stored, I assume, stored somewhere internally in Google Cloud. For how long time do you guys save them? Like if I, for example, want to have a alert like, do some aggregation for like a year, would I be able to do that?
Yeah, we've just increased retention interval for custom metrics, which is what I showed you today with Open Census, to 24 months. We're going to increase retention interval to platform metrics to that long as well. So I think the answer you're looking for is 2 years. And
would you keep same resolution of the measurements? Like if you, I don't know, I assume it's like in Prometheus, you sample every like 15 seconds or every 1 minute. You would keep that resolution for all these 2 years?
No, as you go farther back in time, it becomes less granular. And I think we have documentation somewhere that describes exactly what the granularity is, but we do not keep every raw data point for 2 years.
Yeah. Okay. Yeah. Understood. Okay. Yeah. Thanks.
Mm-hmm. Salim, maybe you get another one.
Okay. So what are some competitive tools to this?
Datadog is probably the one that I see out there the most. They've also fairly recently added SLOs to their suite of capabilities, which I was very happy to see. Honeycomb is much smaller, but I think have fantastic some fantastic technology. They take a different approach. Instead of kind of separating their data into different classes of data, so like the typical 3 pillars of observability would be metrics, traces, and logs. Honeycomb treats everything as events, which gives them a lot of really powerful querying capabilities. They're a small company and a small shop, but I think they're doing really cool stuff, and they have some excellent folks running the company and doing the work there. And then you have the more traditional players like New Relic and AppDynamics who have been doing, ops monitoring for a very long time, and I think are starting to adopt some of this language around SLO and service level monitoring. To kind of fit more with SRE practices.
Yeah. And what is the pricing for this?
Yeah, cloud monitoring at Google, we basically charge by how much data you send us. So we do not charge you for retention of data, we charge you for ingestion. Basically, it's like how many metrics, for metrics, for example, it's how many metrics and how often they're sampled. For logs, it's just how much log data there is. Traces, it's also just the number of trace spans. So for us, it's like more or less a purely volume-based pricing.
Okay. And how does the pricing compare with your competitors?
I would say favorably, to say the least. Because we are kind of positioning cloud monitoring, the cloud ops suite in general, as the first party provider for Google Cloud, less so than a direct competitor to a Datadog or someone like that. We're not really looking to capture market in the same way that they are. We're also not looking at it as like a primary source of revenue, right? We have what people really use Google Cloud for, the same thing they use other clouds for, which is like compute, managed services, things like that. You need to have observability in the platform, but it is not the thing that people come to your cloud for.
So this is more a supporting service, yeah.
Yeah, I mean, it's a service that doesn't have any value on its own, right? Unless you're running services, and it's also not a service that you're going to use unless you have some significant workloads in Google Cloud already. So we're not looking. This is not. It's not that expensive.
Well,
I think it's the short answer.
Speaking of, you said unless you have stuff running in Google Cloud, but wouldn't you be able to, if we were running stuff in Azure or AWS, wouldn't you be able to still use this? I would think so, right?
Yes, theoretically, you absolutely could. In practice, it's going to be much easier if we use the first-party toolkits in those clouds, right? So Azure has, I don't actually know what they call their stuff. AWS has, was it CloudWatch and CloudTrail and all those things, X-Ray. And it's easy to use the stuff that the cloud provider gives you, right?
Yeah.
It does take work to wire up multiple clouds under a single observability umbrella. If you're really going to be 50-50 for the long term, maybe that makes sense. It makes sense to unify observability in a single platform.
Yeah.
If you're, let's say, 80-20, then it might make sense just to use wherever the 80% is and do it that way. So I think, yes, theoretically, we absolutely do have multi-cloud, hybrid cloud capabilities, both natively and through integrations. But in practice, what most people that I've talked to end up doing is they use the observability stuff from the cloud where the workload is.
Interesting. Yeah. Yeah, one of the things we do is we have a control panel, and we deploy using the control panel, we deploy our clients' workloads into their own cloud account, be it at Azure or GCP or AWS. So, but we haven't dealt with this issue yet. So, it's interesting that you're right. It would make more sense to just keep the logs and keep everything in that platform instead of shipping everything across to another platform. So,
yeah, metrics might make a little more sense because the volume of data is smaller, and it's easier to correlate metrics from multiple sources in a single view.
Yeah.
Logs are just voluminous, and so shipping logs across clouds you're just going to pay a lot of egress charges.
Yeah.
So you really have to have a way where that makes sense in order to do that.
Yeah. Okay. Well, I want to ask you how you guys do this at what are your criteria and what are your thresholds at Google? But I guess they would vary from product to product and from.
Yeah, absolutely. I mean, the publicly available ones, if you just search for Google Cloud SLA, you'll see the publicly exposed ones. And yeah, they vary. Typically, you can basically pay for more reliability. So one easy example is cloud storage. We have multiple classes of storage, and as you pay more, the reliability improves. Some of the characteristics do not change. So for example, latency for us does not change between classes of storage. Durability does not change. But the reliability of retrieving the data we have a different SLA for multi-regional versus regional buckets, for example, versus like cold line, the cold storage ones. And obviously it's more expensive for us to have multiple copies of data in multiple regions, and therefore we'll charge you more to do that. You can also, there's other services, for example, something like Spanner. You can have global Spanner versus regional Spanner. Global is more durable, more reliable, quite a bit more expensive. Big table, you can run a 3-node cluster, which is the minimum that we recommend for production reliability, for one fee, and you can run a 1-node cluster, which is obviously going to be as reliable as that one node for a lower fee to manage costs. So we absolutely give you the kind of the ability or the option to say, like, yes, I need a more reliable service, so I'm going to pay for it to have more reliability from the platform itself.
Yeah. Oh, how interesting. Yeah. Okay. Well, I'm done with my questions. So if anybody else has any
good questions, thank you.
Yeah.
I would ask a couple of more questions.
Yeah, go ahead.
Sure thing.
Yeah. So by the way, I apologize if so my connection dropped in the middle. So if I ask something that have been already asked, I apologize. So I understand that the CLI is basically some sort of query against existing metrics. How do you guys compare? I mean, I personally work with Prometheus a lot. Not a lot, but yeah. So how do you guys? I mean, and from what I understand, SLI is some subset of what Prometheus offer, right? And I guess I understand why you decided to implement a subset of that functionality to make it more probably reliable and more available. But how would you compare the feature set of Prometheus to what your system offers?
Yeah, that's a good question that I don't know that I have an easy answer to. I think the one big thing is that Prometheus is fundamentally a way to gather time series data. The stuff that you can then do with that data is sometimes, it varies, right? So for us, for example, we have a very specific viewpoint on what you should be doing with that data, which is you should have metrics for SLIs, you should have metrics for observability. We also give you the ability to do things like logging and tracing, which obviously Prometheus does not get into, and so you need other toolkits for that. Our service is fully managed, right? So you're not dealing with any of the infrastructure stuff. It's just there for you as you need it. Whereas Prometheus is something that you have to manage on your own. With that said, we have lots and lots of customers, lots and lots of GCP customers use Prometheus and don't necessarily use our monitoring capabilities. We also have another set of customers that use both, that use Prometheus, that actually do the metric instrumentation and then use the integration to feed those metrics into cloud monitoring because they like things like SLO monitoring. They like the alerting that we can do. They like the retention that we offer. They like the ability to build dashboards with us more than they would choose to use Grafana or something like that. So it is like, I'm not here to say like, hey, here's ways in which we're better than Prometheus and here's ways in which we're not. I would say that they're both like fully featured monitoring toolkits. Our one big advantage is like we're in the platform. And so if you're running on things that are like not GKE, for example, if you're using our managed services, all the services are going to automatically emit metrics into the monitoring platform. So if you're using, App Engine, BigQuery, any of these other like fully managed or serverless offerings, they're all already fully instrumented for monitoring. Whereas if you choose to use a third-party toolkit, whether it's Prometheus or someone else, you have to do that work yourself. That's honestly our biggest advantage, but it's the same thing it's the same advantage that any other first-party provider is going to have, right? It's the same advantage that CloudWatch has over Prometheus. Is the stuff in AWS is already doing it. It's the same advantage that Azure has, right? The Azure services are already being monitored without the need for you to do anything. So it's just a question of really, do you want to use the cloud providers toolkit or do you want to go the open source route? That's the biggest decision point.
Yeah. Okay. So you mentioned time series. So did you guys have your own time series database implementation?
Yes. Yep. Absolutely.
Okay. Yeah. And you obviously handle the scalability of
Yep.
that.
That's right. Yep.
Cool. Yeah. Very interesting. Yeah. Thank you.
Yeah, of course. Folks, does anyone else have any questions I can answer?
Yeah.
Seems like a no.
Well, this is great. So thank you so much, Yuri.
My pleasure. Thank you for having me. Really appreciate it.
Yeah, and I'm gonna put up the recording for this, so we'll send you a link for this later on.
Great. Thank you so much.
Okay.
All right. Thanks, folks.
All right.
Pleasure to meet all of you.
Okay.
Take care.
Take care.
Thank
Bye.
you.
Thank you so much.
Trying to
Take care.
unmute.
Bye.
Okay.
Okay. Thank you.